All right, in this video, I'm going to work a little bit more on this redesigned SAT practice test 1. So this is section 3, which is the no calculator portion of the math test. In this video, I'm going to do problems 6 through 10. So in a previous video, I did 1 through 5 here. Now I'm going to talk through 6 through 10. So the way 6 starts out, it says, a pediatrician uses the model above, h equals 3a plus 28.6, to estimate the height, h, so h means height, that's convenient, of a boy in inches, in terms of the boy's age, A. Okay, so the variables make sense. This is his age, this is his height. Between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Okay, there's two ways to do this. The quick way to do this is to understand what these two numbers mean. This 28.6 tells you the height of the boy when A equals 0. So you're like, wait, how can the boy be 28.6 inches tall when his age is 0? Well, you're right that wouldn't make a lot of sense. That'd be a really big baby. But again, remember, this model only applies when the kid is between 2 and 5. So, but even though you're not using this when A equals 0, it still helps you understand what these coefficients mean. When A equals 0, H equals 28.6. This is the kid's height when he's 0 years old. And then what happens is every time A increases by 1, we add another 3 to this number. So when this question asks you what is the estimated increase in inches of a boy's height each year, that's exactly what this 3 right here represents. The answer is 3. The quick way to answer this question is to understand what those numbers mean, and then just plug it in and get 3. Another way you could answer this question, this is a longer way, but this is if you look at this and kind of blank and can't remember what these mean, plug in some values. Say if A equals 2, well, then I got 6 here plus 28.6 more. So I will get 6 plus 28.6. Maybe this is H equals 6 plus 28.6, which is 34.6. Like, how does that help you? Well, note that the question is asking you what is the estimated increase in inches of a boy's height each year? So if I pick 1 year later when A equals 3 and calculate what the height would be equal to, 3 times 3 gives me 9. Plus 28.6, you add up those numbers, you get 37.6. It looks like when A increased by 1, this number went up by 3. It looks like his height increased by 3, which is exactly what we figured out before. Again, I don't recommend doing it this way, but if you get stuck and you get pressured or flustered in a test, or if you have time at the end to check, here's a way you could talk yourself through your answer. All right, number 7. Number 7 is not nearly as bad as it looks. You look at number 7 and you kind of freak out. What am I ever going to do with all these letters and numbers? Note that the formula above gives you M in terms of a whole bunch of other stuff times P. So yeah, R represents this percentage rate, and N is the number of months, and blah, blah, blah. None of that will be relevant. All you're asked is which of the following gives P in terms of M, R, and N. So really what it's saying is this equation right here, can you solve it for P? Can you get the P all by itself over here? Well, really what I have is M equals some big mess, I don't know what the hell it is, divided by some other big mess. So A is all this stuff right here, and B is all this stuff right here. And don't let it overwhelm you because it won't matter what it is, times P. This is what you're given. M equals A divided by B times P. And what you're asked to do is get the P all by itself. Well, the way I'd get the P all by itself is I'd have to get rid of the B and get rid of the A. Get these over to the other side of the equation. Multiply both sides by B, and you get M times B equals A times P. And now divide both sides of the equation by A, and you get M times B divided by A is equal to P. But remember, B is all this stuff, and A is all this stuff. So all we're saying is that P is equal to M times the stuff that used to be on the bottom divided by the stuff that used to be up on top. Which of these gives you M times, okay, they all do, the stuff that used to be down on the bottom, so this 1 plus R, blah, 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 all this stuff should be up on the top now. It's not up on the top here. It looks like it is up on the top here. Right, here is what I am referring to as B. And so I already know my answer. It has to be this thing right here. I could take it a step further and be like, I'm supposed to have an A down on the bottom here in my final answer. Oh yeah, it looks like I do. There's the A there. So I end up with the right answer. Just an FYI, MB over A is the same as b over a times m. The fractions freak a whole lot of people out, but when you're multiplying b over a times m, you can think about this m as m over 1. And when you're multiplying fractions, you multiply straight across. So the b and the m get multiplied, which go here, and the a goes here. So that's why this is really the same as this. All right, number 8. We are told that a over b equals 2 and asked what is the value of 4b over a. There's a lot of different ways you can do this problem. What I think the easiest way is substitution. And so I know the way you recognize that maybe you'd be doing a substitution problem is you'd recognize that you have two different variables floating around. I have an a and a b over here and an a and a b over here. So what I would do is take this equation, take one of my two equations. I pick whichever one is easier to deal with, which this is the only equation I have in this case. So I'd have a over b equals 2, and I'd multiply both sides by b. So that it says a equals 2b. Why would I do that? Because I want to solve for a so that I can plug it in up here. So now I can take this thing and I can say I got 4b divided by a. But instead of writing a, I'm going to write 2b. Because from over here I figured out that a is 2b. So that gives me this mess here. What do you do with this thing? Well, I got a b on the top and a b on the bottom that I can cancel out. So this just equals 4/2, aka 2, which is the answer right here. That's one way you can get the answer. I think that's probably the easiest way to get the answer, but since I'm showing multiple ways to get answers, another thing you could notice is that I want 4 times what I want is 4 times b over a. 4b all divided by a is the same as 4 times b over a. And if I knew what b over a was, I could just multiply it by 4 and be done. I don't know what b over a is, but I do know that a over b equals 2. If a over b equals 2, then b over a equals 1/2. So I get 4 times 1/2, which gets me to the exact same 2. How did I know that if a over b equals 2, b over a equals 1/2? Well, you can think about it as you're taking the reciprocal of both sides of the equation, kind of flipping them both upside down. Or you could think about it algebraically. I multiply the b over to this side, I divide the 2 over to this side, I divide the a over to this side, and I get that b over a equals 1/2, which allows me to plug it in here. I think the green method, the substitution method, makes more sense, but the blue method is another way you can do this problem if you are so inclined. Number 9. Number 9 is one that's meant to just mess with you. There's no reason for the test writer to write the problem like this other than to kind of confuse you and hope you make a little mistake. What is my big problem with this problem? The order of the variables. I have 2 equations, which is fine. That's going to show up a fair amount of times in tests like these. 3x plus 4y equals negative 23. Okay, but down here, why did they write 2y minus x? They could have just as easily written negative x plus 2y equals negative 19. It means the exact same thing, but it's a lot less likely that you'll make a mistake if your variables are in the same order. You're given these 2 systems of equations and asks which of these pairs is a solution to the system of equations. What you need to know is the first number listed in these orders pairs is always your x-coordinate. And I guess it says that right here. The first thing is the x, the second thing is the y. So what you're probably tempted to do is take this negative 5 and plug it in for x, and take this negative 2 and plug it in for y. That gives me negative 15 here and negative 8 here. When I add those, yeah, I do get negative 23. What about down here? Negative 5 is positive 5 plus 2 times negative 2, which is negative 4. Positive 5 plus negative 4. I don't think that's negative 19. I don't think this is a solution. The downside to that is I just did a whole lot of arithmetic in my head without the help of a calculator under the pressure of a test. There's a decent chance I'm going to get through all of these and be like, whoa, none of them work, or I'm going to make some sort of mistake. So while you could plug these in to solve, there is a method that makes these easier to do. Actually, there's several methods that make these easier to do. There's a substitution method, but frankly, there's a way that I prefer. I think it's better than the substitution method, and it's adding up equations. And so the idea is, I could just add up the equations right now, but it wouldn't help. But if I can multiply one of my equations by some number, so that later on when I add up the equations, one of my variables goes away. So maybe I'll just work through the problem, then we'll talk about what I'm doing. So one thing I could do is maybe I could multiply this bottom equation by negative 2. If I multiplied this bottom equation by negative 2, the top equation would stay the same. I'd still have the 3x plus 4y equals negative 23. But in the bottom equation, if I multiplied the left-hand side by -2, I'd have -2 times -x, which is positive 2x. I'd have -2 times positive 2y, which is -4y. And then I'd have -2 times -19, which is a bit much to do in your head under the pressure of a test. But I guess I could tell you that the two negatives cancel out, so really you're just figuring out what's 2 times 19. And 2 times 19 is damn near 2 times 20. And you probably know 2 times 20 is 40. But you only have 19 of these 2's, not 20 of these 2's, so you're kind of 2 less than 40. At any rate, you get 38 here. Or maybe you write that off to the side to do that multiplication. If you can get to here, this problem becomes a lot easier. You can do this little trick called adding the equations. So I have this equation and this equation. I can add them vertically. I can take my 3x and my 2x to get 5x. I can take my positive 4y and my negative 4y to get 0y, which I don't even have to write. And then I can take my 38 and my -23, and that gives me 15. Note that my y's went away. If my y's didn't go away, this wouldn't have helped me at all. It would have given me an equation with x's and y's. I would have been right back where I started. So it was really important that I got rid of one of my variables. I chose to get rid of my y by multiplying this second equation by -2. But there's other ways I could have gotten rid of one of my variables. I could have gotten rid of my x's instead of my y's if I wanted to. But I didn't. I chose somewhat arbitrarily to get rid of my y's. I got rid of them. I now know that 5x equals 15. So if I divide both sides by 5, I get x equals 3. That may or may not be enough to solve my equation. I know that x equals 3. I go over here. It looks like there's only one equation that has an x coordinate equal to 3. So this is my answer. Okay, now some kind of behind the scenes stuff. Why I did what I did. When I glanced at these answers originally, I noticed that they all had different values for their x coordinates. But these two guys had the same values for their y coordinates. So that made me not want to solve for y down here, because if I had solved for y and I ended up getting -6 as my solution for y, I mean, I wouldn't know before I did the problem what I'm going to get, but if I got -6, then I wouldn't be done, right? I wouldn't know whether my answer was C or D. But when I looked at my x coordinates, I noticed they were all different. I told myself, all right, if I could figure out just the answer to x, I'd be done with the problem. I don't even need to figure out the answer to y. By the way, once you figure out the answer to x, you can get the answer to y relatively easily. You can take this and plug it into any equation that you've written up here, any one that has x's and y's in it. So, I don't know, maybe this top one here. 3 times 3 gives me 9. 9 plus 4y equals -23. Subtract 9 from both sides, you get 4y equals, what did I say, subtract 9 from both sides, -32. And you divide both sides by 4, and you get y equals -8, which sure enough matches up here. But you didn't need to check all that because x was unique. So that's my answer. I probably should call this good, but just in case people were just learning this equation addition strategy, I want to show you one more way you could have done this problem using equation addition. I could have, again, left my first equation alone, 3x plus 4y equals -23. Maybe I'll say or. And then decided I want to get rid of the x's. That wouldn't have been your smartest thing to get rid of the x's, because then you're solving for y, and again, there's multiple answers that have the same value of y. But suppose you did this. You multiply everything down here by 3, I get -3x plus 6y equals 3 times -19 is -57. And now when I sum these up, note my x's go away. So I just end up with 10y. And if I sum these guys, -23 plus -57 gives me -80. So I get y equals -8. So even without doing any of this work over here, I could have concluded that y equals -8, and I would have gotten a little bit lucky that my answer, -8, only showed up once in this list. Other ways you could do this with substitution. You could solve one of the equations for one variable and plug it into the other equation. I just find that gets a little bit messier algebraically. I kind of prefer this angle addition strategy. Maybe I'll call that good. All right, number 10 here. For the function g defined above, a is a constant, and g of 4 equals 8. Okay, what you need to know is that this is telling you when x equals 4, the g of x equals 8. That's all encoded in here. It's saying g of x, the value of x, what's inside these parentheses, is the 4. And what that's equal to, this entire g of x thing, is 8. So you can take this equation and you can rewrite it, except instead of writing g of x, you can just write 8. because you figured out that when x equals 4, g of x equals 8. So copy down this equation. Everywhere you see an x, write a 4 instead. Everywhere you see a g of x, write an 8 instead. You get this equation here. What you're asked is to figure out the value of g of negative 4. So you're supposed to figure out what g of x equals. Maybe I should write this somewhere. This is saying, what is g of x when x equals negative 4? That's the question that's being asked here. And so you might think you can just go plugging in, change all the x's into negative 4s, and kind of in this one you can. There's a trick way of doing this one, but I'm going to show you the long way to do it first, and then I'm going to show you the shortcut way. So you take this problem and you're like, all right, I have this constant a. I guess I should solve for this constant a. I have 8 equals 16a plus 24. Where that came from is 4 squared gives you 16. So I have 16 times a plus 24. I want to get the a all by itself so I can figure out what number a is equal to so that I can put that into my equation here and figure out what g of x equals when x equals negative 4. To get the a all by itself, I'd first subtract 24 from both sides of the equation. I get negative 16 equals 16a. So now if you divide by 16, you get that a equals negative 1. And now you have all the information you need to solve this problem. What is g of x when x equals negative 4? Well, if x equals negative 4, I have a, which I know is negative 1, times negative 4 squared plus 24. So I would have negative 1 times positive 16 plus 24. I would have negative 16 plus 24. In other words, I would have positive 8 as my answer. I mentioned that there's a shortcut way of doing this. There's a very shortcut way of doing this. This is kind of the longhand way. This will work on any problem of this type. But this specific problem, there's a trick to it. If you recognize that the only thing that's different between here and here is the value of x changes from 4 to negative 4. But then you think about what's happening to x in this equation. X is being squared. 4 squared is the exact same as negative 4 squared. Either way, it's 16. 4 squared is 16, negative 4 squared is 16. So if x equals 4, and I know that that makes g of x equals 8, then it must also be true that when x equals negative 4, g of negative 4 would be equal to positive 8. Because 4 squared is the exact same as negative 4 squared, and the only place an x shows up in here is right here where it's being squared. So you could have gotten this answer really quickly, but I think most people, well, I don't know what most people would do. If you didn't see that little trick, you could have solved for a and then plugged it back in to get your answer. All right, I'll stop this here.